Newton's method. It is a method to approximate numerical solutions to equations that are too hard for us to solve by hand. The idea is to pick an initial guess x sub 0 such that the f of x sub 0 is reasonably close to 0. And this method is extensively used for analysis of flow in water distribution networks. This is named after Newton and Joseph Braxton. So for example, this one is the curve y f of x, and the point, this one is point P. This one is point P, or this one is point P1. This one is point P2. And this one is your root to be found for the certain function, the curve y equal to f of x. And this makes use of the tangent line equation. This one is point P x sub o in if x sub o, this one equivalent to y, and the equation by tangent line to the curve is equals to y minus if x sub o equals to a prime x times x minus x sub o. So when x sub o, actually this one is y minus y sub 1 equals to slope m times x minus x sub o, referring to this point there and this tangent line. So when x sub o is near to the root r is 1, the tangent line will intersect the x-axis. So setting x equals to x sub 1, or x sub o equals to x sub 1, and y equals to 0. So you have this one 0 minus f times x sub 0 equals to f prime of x times x minus x sub 0. Solving for x sub 1, x sub 1 equals to xo minus f times x sub o all over e prime of x. So for the next iteration, or for the next approximation, your x n plus 1 equals to xn minus f times x sub n all over e prime x sub n. So this one is known as Newton's method. So this is Newton's method. Method in finding roots of the function So this was a Newton's method in finding function of f of x. So for example, determine the root of the curve f of x equals to x cubed plus x minus 5 by Newton's method using initial approximation value of letter A 0, B equals to 1, and C equals to minus 1. So these are the approximation value to be used in finding the roots of this curve f of x. So as letter A, x equals to 0 as initial root value approximation. So for iteration number 1, so iteration in number 1, x sub 0 equals to 0, your initial value for the approximation. Just substitute f of x equals to x cubed plus x minus 5 equals to 0 cubed plus 0 minus 5 equals to minus 5. So the f prime of x equals to 3x squared plus 1 equals to 3 times 0 squared plus 1 equals to 1. So for the x in plus 1 equals to x sub 0 minus if x in over f prime x in. So substitute equals to 0 minus 5 over 1 equals to 5. So this one is x1. For iteration in equals to 2. So x1 equals to 5 if sub 5 equals to 5 cubed plus 5 minus 5 equals to 125. If prime of x equals to 3 times square 3 times 5 square plus 1 equals to 76. So x in plus 1 equals to 5 minus 125 over 76. This equals to 3.35523. is x sub 2. So for the error, for iteration in equals to 3. So for in equals to 3, x sub 3 equals to just follow the equation there, equals to x sub 2 minus x sub 1 over f prime of x sub 1. So this algorithm, so the process of iteration is repeated until the desired accuracy is obtained. See the attached table. So for the letter A, approximation x equals to 0 for this function x cubed plus x minus 5. The approximation or the iteration number 7 and 8, your value of x, the root is just the same as 1.51598, and the next iteration number 8 is the value is just the same. So it is on these iterations that the root is considered more accurate, and we have the absolute column absolute error. The error there is this one, so it is somewhat negligible, and a percent relative error. The error there is xn minus 1 minus x sub in absolute value, so you take absolute values there, never mind this sign, and the relative percent error equals to this absolute error divided by the x in plus 1, of course, times 100. Never mind this sign, so this one is the result. When we follow through using the approximation value of x equals to 1, the initial value or the guess on your roots of this curve. So use x sub n equals to 1 first iteration. So you have the following values of f xn and f prime xn there. The resulting value of x sub n plus 1 is this one until you have the same result for the x sub n plus 1 in iteration 4 and iteration 5. So the same value on letter A. When we try the same thing for the letter C, approximation using first 1, now x equals to 1, so compute x sub n. X sub n is start with negative 1, then compute everything there, then the resulting new value of the x is 0.75. Then use this 0.75 here as your x sub 2 or x sub 1 there for the second iteration. So you have the result, and the same result will be obtained on number 6 iteration 7 and 8. So the value of x is equal to 1.51598 is the desired root for the equation of the curve. So the answer would be 1.5